Building the first XB-70A had been a challenging job. New fabrication and assembly techniques, revolutionary electrical and hydraulic power systems, and advanced instrumentation all had to be developed. Above all, the mission required a totally new aerodynamic design, a design that may be the key to man's future conquest of his own atmosphere. But the flight test of this supersonic giant presents even more dramatic challenges and more dramatic achievements. With North American's Al White at the controls and Colonel Joe Cotton as co-pilot, the first liftoff occurred on September 21st, 1964. The first three flights demonstrated excellent low-speed handling characteristics. Stability and flutter tests proved the basic soundness of the design. The pilots were well satisfied with the plane.
And I think that both Joe and I are very happy with the way the airplane was controlled. Had no problem with the landing, no problem with its visibility, and a lot of the things that we've been thinking that there was some question about, and I'm just real tickled with the way the thing went.
On the third flight, the aircraft broke through the sound barrier 3 times.
Boy, that's do go now.
Progress toward Mach 3 had begun. The wingtips were lowered 25 degrees for the first time on the fourth flight. Moving these 500-square-foot wingtips is a major achievement. The first time such a large structural portion has been repositioned in flight. With the tips up, the XB-70 retains its superior subsonic handling qualities. Lowering them provides stability at high supersonic speeds, reduces trim drag, and reinforces compression lift effects. Phase 1 testing was completed in 34 days, with 55 minutes logged above Mach 1. Total flight time, over 5 hours. Next on the schedule was a complete proof loading. Controlling and stabilizing surfaces were loaded to their limits. Deflection was as predicted, and the surfaces met all requirements of high-speed flight. After thorough proof loading, the plane was ready for Flight 5, the start of Phase 2 tests.
We'll put the wingtips down on 3, 2, 1, now.
Tips look real steady.
With the tips full down, 65 degrees for the first time, the plane shot to a new high speed, Mach 1.6. Supersonic flight with folded wingtips soon became familiar. They are moved down 25 degrees at 0.95 Mach and to full down at Mach 1.4. The design innovation is completely successful. As Colonel Cotton remarked,
she was really born to fly with the tips down.
After decelerating, engines were shut down and restarted. There were 2 restarts made at Mach 1.4. Another was made at a lower speed.
Okay, starter up, Fitz. Air start is on. Caliper 5160, throttle coming to idle.
Inlet ducts, bypass doors, and ram air scoop were successfully operated. But speed and altitude highs, Mach 1.85 and 50,000 feet on the 7th flight, are only the most obvious measures of achievement. The XB-70A is not only a new aircraft, it's an airborne laboratory, a chance to gain information which will prepare the way for the airplanes of tomorrow. During flight, ground recording devices include a continuous telemetered record of 36 key information channels. These allow procedures to be varied to make sure all test information is gathered.
What's your Mach number now, Al?
At 1.1.
After the flight, a graphic record is provided by 100-channel recorders. 2 magnetic tape reels bring back the bulk of this information. 90 million individual measurements from nearly 800 separate sources throughout the plane. The final results are reduced by computers and high-speed printers to simple, readable form. Bit by bit, volume by volume, an invaluable reference encyclopedia of sustained supersonic flight is being compiled. The airplane has demonstrated its ability to transcend flight problems as well. Flight 9, for example, was shortened after a pressure drop in the utility hydraulic system. The landing at Edwards Air Force Base was the heaviest ever recorded. With the plane weighing 419,000 pounds, it was more challenging than an aborted takeoff test. All systems performed well during approach, landing, and rollout. Hydraulic problems, which had also occurred on Flights 2 and 6, were later solved by replacing the rigid steel tubing with newly developed flexible tubing in specified areas.
Hydraulics good, all pegged, 205, looking good, hydraulics.
The windshield ramp was moved to the up position for the first time during the 10th flight. This reduces drag and turbulence at extreme supersonic speeds. With the wingtips full down and the windshield ramp up, the XB-70 assumed its Mach 3 aerodynamic configuration for the first time. More than 50 minutes of the hour and 40-minute flight were spent at or above Mach 2. Top speed was Mach 2.3. As the plane moves beyond Mach 2, the advanced inlet design becomes of paramount importance. In order to cruise at up to 2,000 miles an hour, the shock wave must be brought inside the 80-foot-long inlet and automatically positioned by movable ramps and bypass doors. A continuing series of successful inlet duct tests was begun on the 8th flight. More important, the inlet duct was repeatedly unstarted above Mach 2, forcing the shock wave out, then easily restarted. The airplane left the Edwards runway on its 12th flight, weighing more than 500,000 pounds, a new weight high. Inlet duct tests had been performed, and flight objectives of Mach 2.6 and 65,000 feet had been reached when, after 30 minutes above Mach 2,
I got very high engine vibration.
and 30 seconds later,
Give me a heading home. Right. 210.
the landing on the lake bed with only 4 engines emphasized the plane's ability to withstand totally unforeseen conditions. A small piece of stainless steel skin from the apex of the wing had been ingested into the right duct, damaging engines 4, 5, and 6. The apex section was later revised to prevent a recurrence. The airplane moved close to its design goals, Mach 3 at 70,000 feet, on the next 4 flights. The 15th flight was typical of these threshold missions, designed to test the plane's response to sustained high-speed cruise before proceeding on to Mach 3. Temperatures become vitally important as the plane cruises at speeds and altitudes never before invaded by such a giant aircraft. Though the air outside is thin and cold, the plane's skin temperatures build up as speed is increased, placing great demands on structure and control systems. On the 15th flight, at 66,000 feet altitude and a speed of 1,900 miles an hour, the plane experiences heat soaking in a temperature of more than 500 degrees for 20 minutes. The biggest single barrier to Mach 3 flight, heat, has been overcome. Through the 16th flight, more than 23 hours had been spent in the air, more than half that time above the speed of sound, including 6 hours of cruising above Mach 2, and more than 1 billion individual measurements taken for NASA and Air Force research projects.
5, 4, 3, 2, 1, brake release.
Each of the 6 J-93 engines produced by General Electric is capable of delivering 30,000 pounds of thrust and will produce approximately 200,000 horsepower at Mach 3 and 70,000 feet. On its 17th flight, the airplane achieved its initial goals: speed in excess of Mach 3 and altitude of 70,000 feet.
that big magic number, boy. That's a boy. Congratulations to both of you.
This was accomplished in less than 25 hours of total flight time, and just over 12 months after the first supersonic flight. The XB-70A has achieved these goals without any aerodynamic changes required. This in itself is significant, and becomes even more so when the revolutionary firsts, such as the multi-shock air inlet duct, the canard delta wings, and the folding wing tips are considered. Information obtained in the XB-70's progress to Mach 3 will provide further understanding of the operational problems associated with flight of a large supersonic aircraft, and will contribute to this nation's program to develop a successful supersonic transport. The date was October 14, 1965. It was appropriate that the two men most involved in flight testing the Airborne Research Laboratory, North American's Al White and the Air Force's Colonel Joe Cotton, were at the controls when the XB-70 attained its magic number.
Congratulations, buddy.
Congratulations, Al. Thanks a lot, Joe.
All the way. I won't forget to say that.
Thank you.
Thus, the result of the XB-70 flight test program to date is not only a series of record-setting achievements, it is a significant milestone in the history and the future of manned flight. Totally new aerodynamic design, a design that may be the key to man's future conquest of his own atmosphere. But the flight test of this supersonic giant presents even more dramatic challenges and more dramatic achievements. With North American's Al White at the controls and Colonel Joe Cotton as co-pilot, the first liftoff occurred on September 21st, 1964. The first three flights demonstrated excellent low-speed handling characteristics. Building the first XB-70A had been a challenging job. New fabrication and assembly techniques, revolutionary electrical and hydraulic power systems, and advanced instrumentation all had to be developed. Above all, the mission required stability and flutter tests proved the basic soundness of the design. The pilots were well satisfied with the plane.
And I think that both Joe and I are very happy with the way the airplane was controlled. Had no problem with the landing, no problem with its visibility, and a lot of the things that we've been thinking that there were some questions.